Hello, everyone, and welcome to the EVN Disrupt podcast. My name is Zorian. I'm the editor of the creative tech section here at EVN Report. Today, we're launching a short podcast series with guests from the recent Digitech Summit. We were happy to be a media partner of Digitech and are excited to bring to you a series of conversations with speakers from the summit. Our first guest is Yervant Zorian, Chief Architect and Fellow at Synopsys, and the President of the Synopsys Armenia Research and Development Site. Dr. Zorian joined us to reflect on the past 2 decades of Synopsys' presence in the country. We also discussed the current trends in the semiconductor industry, its impact on the EDA market, and why more companies are increasingly opting to design their own chips in-house. Thank you for listening. Dr. Zorian, thank you so much for joining us today.
My pleasure. Thank you.
I want to start by speaking about Synopsys. So I believe it's next year. It'll be 20 years that Synopsys is in Armenia. I just wanted to give you a chance to reflect on that. Take us back to those early days. Did you think that 20 years later, it would be what it is today in Armenia?
Actually, no, it's more than what I expected personally, especially at the beginning in 2004 when we came here. We came by acquiring 2 small startups, 80 people, 40 people, of course, US-based startups with a strong R&D here. Diasporan-founded companies, private. So we acquired 2 companies, and suddenly we had teams. I'm speaking as Synopsys, as a person I was here prior to that. As Synopsys, we were able to get a very good chunk of people, very talented, quality results, and so it was a nice start.
Right.
Immediately after, we had an opportunity to have another acquisition a year later of a third company, which happened to be a public company in that case. But again, the R&D based in Armenia, the front office in Silicon Valley. Again, diasporan Armenians who were directing it. I was part of the board as well. So that was the third acquisition. And with that, we started already to have our presence. And Armenia became part of the Synopsys culture, the Synopsys vocabulary, the mentality, and so, which was surprising to me because a large public company as Synopsys and Armenia became a nice, productive entity inside Synopsys. And that was 20 years back.
Right, yeah. I'm curious what it was like pitching the idea of acquiring a company in Armenia and building out a presence here back 20 years ago, because these days we hear about it with companies like ServiceTitan and Disco coming to Armenia, even bigger players such as NVIDIA. But now the ecosystem is much more built out.
Yes.
In 2004, the picture was obviously much different.
Absolutely.
What was it like selling the idea to Synopsys?
It was not very easy because Armenia was not known as a technology center. It was known to some of us as Armenians, but for non-Armenians to bring a public company to convince the executives and the board to come and invest in a company that's mostly in Armenia, it was a challenge by itself. We need to justify why Armenia, what can it do? But they had unique technology here. That was one of the reasons. The second was the workforce, the talent that we had. It has proven itself. So we brought in a few people, they got interviewed and so on, and we made that decision. But I think it was risk-taking at the same time.
Yeah.
Some of the executives, 1 or 2 of the executives came and visited Armenia to see it in a tangible way. But then got convinced, and then we worked hard to make it a success.
Right. When a large company like Synopsys is looking to enter a new market, mostly through as an R&D center, not necessarily for sales, what are they evaluating besides just the company that they're going to acquire or maybe the immediate talent pool?
They look at a number of things. One of the most important things for us is the stability, the attrition rate, and the quality of the workforce. So once you're happy with the quality of the talents that you have and the attrition is low, because we are in certain countries, there are many countries such as India where the attrition rate is very high. You have 20-25% of the people would change per year. So that's a headache because you train people and then you lose them. You train new people, you lose them. In Armenia, that is very good because the mentality of Armenians when they get employed is to stay for life. So they're used to work for long periods of time. And that was one of the good reasons. As I mentioned, the tradition in the tech domain, the past tradition, the availability of talents was part of it as well. These are the important things. Of course, cost is important as well. Because often in our companies, we look at high cost centers, low cost centers, and so on. So cost is also an important factor, but comes after the other 2.
Right. When you're looking at the ecosystem today, is there a something that needs to be maybe resolved in order to attract more companies like Synopsys here? Is it just a talent shortage maybe? Or?
Yes, that's the most important thing, which is the talent shortage, right?
Yeah.
Which happened more recently because the first period, I was here 10 years before, started to work with Armenia 10 years prior to Synopsys coming here back in 93, 94. We started bringing the first startups from Silicon Valley to build R&D here. The availability of the talents, the supply-demand balance was totally different in the mid-90s. For every job that we would announce, we'll have 30, 40 people submitting candidates, submitting their resumes. Soon after that, it started to reduce. When Synopsys came here, we were already at the age where the supply and demand were balanced.
Right.
That's why immediately after we came here as Synopsys, we started working with universities, to university programs to train, to prepare quality talents and so on, to have the possibility to give them internship at the company and hire from there and so on. So it was necessary to not only rely on the existing workforce, but rather to create the new ones.
Right.
Today, it's far more than that. Today, yes, we worked with 5 universities at the same time. We have about 400 students that are in training for us, bachelor, masters, PhDs, which we hire from. Still, we have lots of open positions that we cannot cover.
Right.
And unfortunately, we're forced to move those positions to other countries.
So there would be the opportunity to have those be filled in Armenia if there was the capacity for it.
Absolutely. Yes. I mean, we keep growing. We grow about 100 people per year. Before COVID, we were 900 people. Today, we're 1,200 people. I mean, it's natural growth.
Right. What is the 1,200 as a percentage of the entire Synopsys workforce?
Total employment of Synopsys, but not only the engineers, including sales, marketing, and other administrative positions, is 19.5K, 19,500, about 500 people. If you look at the engineering side, I would say maybe 15,000 of those would be pure R&D work. The rest are in technical sales, technical support, and so on. But R&D is. So we are slightly less than 10% of the R&D workforce here in Armenia.
In Armenia's office is primarily R&D?
Yes. It's primarily R&D. We have a little bit of support for Europe. We support customers in different European countries, some in India as well from here, but it's mostly new concept development, new product development, but it's true R&D.
Right.
Right. And we have multiple products, and I'm proud of that we do the end-to-end work here. It's not something that has been designed somewhere. We are modifying it, we are porting it to a new technology node. So it's not a secondary type of work.
Right.
We start from the basic research for it, we do the development all the way to quality assurance, to the documentation are done in Armenia. So the end-to-end work is done in Armenia. That creates more dependency, of course. Right. But again, it's a good thing to feel that you are doing prime work rather than
something to be proud
secondary
of.
work.
Yeah, absolutely. Let's talk about semiconductor technology a little bit. So a lot of the exciting tech we're seeing these days in AI and machine learning is powered by some advancements that have happened over the last, let's say, 10 years in semiconductor technology. Synopsys, with their EDA work, is really at the heart of all of this. Where do you see the semiconductor ecosystem today? What are some exciting trends you're looking at?
First of all, I fully agree with you regarding AI. AI is not new. AI was created 50 years ago. We have done that long time ago. But these were software solutions. And they're not very applicable because they're not fast enough to do the decision for you. You have to wait to reach a decision. Meanwhile, your mind is much faster. You will make a decision without AI. AI became real when 2 other factors came. Not only the software algorithms, that is the big data. You need lots of data to work on, and the semiconductor engines to do AI.
Right.
Semiconductor accelerators for AI. And that happened 5 years, 6 years ago, more. 2016, 2015, 2016, we were able to do deep learning.
Right.
Prior to that, it was shallow learning. And
right.
shallow learning is not good decisions. So the accuracy of your decision becomes much more when you do deep learning, 28, 80, 100, 150 layers of neural networks that allow you to do precise decisions. Now, the decisions that we get from AI is much better than our minds do in terms of accuracy of the decision. The human factor, if in image recognition, we do mistakes 4% of the times. Right. So our resolution is 96 in image recognition.
Right.
AI now, it does 99%, not
Right.
96%. So they're better. That's important for self-driving car, for anything that uses image recognition, image analysis. Now, AI is definitely benefiting a lot from semiconductors. But semiconductors, the chips, are the backbone of everything we do, right? Any electronic equipment we use, the backbone is the semiconductors. Your car, your refrigerator, your smartphone, your home equipment, they are all built on semiconductors. But our expectation as users keeps increasing. And because of that expectation, we need to provide more and more. We need to look at it from a provider perspective, that we need to accelerate our innovation constantly in order to give more and more and more. That's what's making the semiconductor designs much more complex, much more capable, faster, but they use more power. Because of that, they give you certain yield or safety risks sometimes if they are not properly prepared. So there are lots of advantages, but at the same time, we have some challenges to solve.
Yeah. In terms of the importance of having companies that do work, semiconductor work in your local ecosystems, there's been a lot of talk in the last few years, especially since COVID, about the importance of growing sort of the local ecosystems in each country, because we saw the issues that we had with supply chains and things of that nature that were disrupted, and it caused a lot of manufacturing and things to really slow down. Is this something that even smaller ecosystems like Armenia should be thinking about, or is it out of our scope for now?
A little bit. If Armenia is in the manufacturing domain, then the supply chain issue can become serious, like any other country where they do manufacture certain things, right? If you're manufacturing cars, if you're manufacturing robots, if you're manufacturing any home equipment, then you need the parts, you need the supply chain, and the chips are among those parts that are coming in. Armenia today is not a manufacturing country by far, right? We're starting to do some, and I hope we can do more. But even during the Soviet times, we were not in mass production.
Right.
We used to do prototypes. We used to do limited set of proof of concepts, right? But to do volume production, it's a different culture, it's a different process, and we're not part of that. So that's not good news. But the good news is that we don't get impacted by the shortages that we know of. The design of systems, the design of chips do not have such issues.
That limitation, yeah.
Because everything is based on soft elements, even though the chip eventually is a hard semiconductor piece, but creating the chip is via tools, via building blocks, and so on. They're all soft matters that don't have shortages as such.
Right. Even if the global supply chain is disrupted as such, the design process is not, you're saying?
Absolutely, absolutely. In fact, during this post-COVID period, when we had shortages of the supply chain, the designs were not impacted at all. In the contrary, we saw more and more designs coming in.
The demand was still there.
The demand was there by the companies, and the continuity of the work was there. Only in some cases, difficulties were that the workforce was not concentrated in the same cities, they got distributed and so on, but not any other material. So we didn't have any shortage of material from the supply chain point of view. In the contrary, we saw many more companies moving into the chip design. Because of the situation during COVID, certain companies decided not to create as much dependencies on others. Companies that used to do only the systems in the past and rely on others to provide them the semiconductor parts, decided that the semiconductor parts have lots of intelligence, have lots of knowledge. So the IP of the products are in the chips. So they decided to do their own chips. Like Apple uses to do their own chips for a long time, but not the others. The big hyperscalers such as Google, Meta, Amazon, Microsoft, they all have their own chip divisions today.
Right.
They design their own, they don't manufacture. They design their own chips.
Right.
The car companies, usually they didn't do their own chips. They bought it from others. The Mercedeses, the Volkswagens, the Ford or Toyotas, they didn't have their own chips. Today, they have chip divisions. They're copying what Tesla did. Tesla does its own chips. Now, Mercedes has its own chips, or Volkswagen makes its own chips. So suddenly, in the past 2 years, we started to see a lot more systems companies starting to become chip companies as well, but not manufacturing. The design of those chips is done by them. For us as Synopsys,
that's great news for you.
Lots of new customers. Yeah.
Right. If this trend continues, what does that mean for the traditional chip makers? How will their role change?
It's a competition. It's a competition because the traditional chip makers will keep doing their chips, but they will supply it to companies that are less capable of creating their own chips, that have less IP. They will buy it from the traditional, let's say, automotive chip providers, NXP, ST, Renesas, Infineon, because the real car companies, we call them the OEMs, will create their own chips. They will supply to the smaller ones. So that will continue, but they will have better ones. They will compete with each other. And there's lots of nice challenges there.
Right. I mean, Apple's always sort of been a more of a niche company in that sense, but do you anticipate even the other mainstream PC makers to start building out their own chips, or will the Intels and AMDs of the world still be powering most computers?
Yes, for the time being, on the computer side, yes, it will be using Intel, AMD, and so on. Yes, Apple has its own for the computers, but Apple also creates its own chips for all the other equipment, right? For the smartphones, for the smartwatches. So we see that happening now.
Right. It's really interesting. I knew about it from a more macro scale of countries being more interested in developing their own semiconductor capacities, but I had...
In addition, because, over time, even though the semiconductor field was well distributed in terms of manufacturing, in terms of design, it has always been distributed. And today, even more. It used to be in the US, Europe, and Japan. Today, there's so many other places they design chip. From Israel to Ireland, every country has chip design divisions. If not their own, it's a global company that has its team over there. Right. So chip design has always been very democratized, very, very well distributed. Manufacturing used to be like that in the past. In the US, we had 15 companies manufacturing chips with the newest nodes, from IBM to AT&T to TI to Motorola. Today, none of them manufactures.
Mostly in Taiwan.
They create designs, they send it to Taiwan or Korea, Samsung. Yeah. So TSMC, Samsung, Intel, they do the manufacturing of the chips. So most of the other companies, same thing in Japan. The Hitachis, Fujitsu, Toshibas used to have their own manufacturing of chips. Today, none of them does. They all rely on Taiwan and Korea to do the chips.
Do you see that trend reversing?
That trend is not reversing too much. What we're seeing, though, is the geographic concentration is getting reversed. So instead of a TSMC being only in Taiwan, they're forcing TSMC to come to the US as well, in Europe too, and so on. So yes, it's getting diversified geographically, but it's still in the hands of those few companies.
Right. They're hedging in that way.
That is correct, yes.
That was a really fascinating sort of breakdown of where the industry is headed. Just coming back to Armenia and concluding our conversation, where do you hope to see Synopsys in Armenia in the next 5-10 years?
Synopsys in Armenia has lots of interesting plans. We are hoping that we'll have enough talents to come in, but lots of exciting work. Because again, this domain is continuing very fast as we're moving towards 1 trillion transistor dies, multi-dies working with each other, which is also a fascinating thing where you can, in one package, you will have multiple dies sitting next to each other. There's so many nice challenges of how you stack them vertically above each other and how they communicate and so on. So technically, there are lots of interesting challenges there. Our engineers are fascinated from now. We see so many patents coming on from our teams in Armenia. I think our mission is to make sure that those most critical, nice projects do come to Armenia. They create that fascination, use the Armenian talent, know-how, knowledge, but advance it. But one of the important conditions, though, to do that is education, is to continue not only educating the new students, but also educating the current teams, that is re-educating, training. So we do that. The nice thing with Synopsys is that once you start working in Synopsys, you have to be retrained all the time because technology is so fast. Every 2-3 years, you have new concept, new ways of doing things. Now, using AI to design your blocks and so on. So you need continuously to be trained as a workforce on one end. So it's a very exciting thing for the people who work because they're part of a continuous education and improvement and so on. So they see themselves in the middle of the world. And they work with the best customers of the world. That gives them also a very good challenge. The problem that we'll be facing is in the quantities.
Quantity of engineering talent?
That is correct. For that, we need to concentrate not only on universities, but before that. The pipeline is not feeding to the universities. We want to increase the number of students in our programs. We cannot because there's not enough number of students. While we keep hiring, if you look at the number of students in the universities, it's stable. It's not increasing. We need to change that. And for that, it's not the problem. It's not the university that is the problem. It's the schools. We don't have qualified teachers in the schools, especially in STEM, especially in the regions. So we need to go, we have discussed this many times in the past, not much has changed yet. So we need to work with the government, with the agencies outside, us as companies as well, we participate in that. But if we don't work with the high schools to bring in those lacking teachers, this high school does not have a math teacher, that high school does not have a physics lab, and so on. So it cannot be. We cannot fill that pipeline, we cannot increase, and we cannot do this exciting work unless we fix the STEM problem in the high schools. And it's not in one or two high schools. It has to be scalable.
Systemic. Yeah.
Systemic. That's why regular education, just training the existing teachers, is not sufficient. I personally believe in e-learning, using the learning technologies. With that, scaling your programs, reaching every single village. If you use dynamic, new, immersive learning solutions, you can have your lab, your expert teacher, and so on, and you scale it.
Do you mean so let's say the best math teacher, the 10 best math teachers in Armenia, right now each teach probably 20 to 50 students. They should be able to teach 500 to 1,000 if you just utilize e-learning methods, is what you mean?
That's one scenario if we're thinking of the personal teaching. But EdTech, education technologies, don't necessitate that a teacher teaches. You can have the system teaching you. You can have dynamic engines with all the media, from video to audio to text and so on. And we do that. I don't know if you're familiar with the Armenian Virtual College. AVC has used the most up-to-date and keep changing and upgrading the solutions to utilize the educational technologies to the best.
Right.
In order to be able to give that knowledge in the most pleasant, most interesting way, engaging, immersive way. And we can do that for physics, for math, and so on, and make it scalable and reach all the schools. So instead of only teaching language, culture, history as AVC does today, we already started. Actually, we have a program now going on as a pilot for teaching artificial intelligence at the high school level.
In Armenia?
In Armenia. We approached the Synopsys Foundation. They were kind enough to provide us the funding for it. We brought the content from Silicon Valley, very nice content for high schools. So 10th, 11th, 12th grade, a 3-year program for teaching AI. The first 2 years is ready already. The third year we're working on. But the outcome is in e-learning way.
How many schools is that in today?
We're just starting pilot. We're doing schools in Yervant, Gyumri, and Artsakh. And the intent is to scale it, to take it to the villages. AI is just one topic. We have to do it in many other topics. But we cannot do all of it ourselves. The good thing is that we are leveraging AVC. So we're using the AVC platform, the multimedia teaching techniques to reach all the corners if possible.
Fantastic. And in those classes, is the role of the teacher more as such a tutor, maybe kind of?
Facilitator.
Facilitator, yeah. Dr. Zorian, thank you so much for the fantastic conversation. I really appreciate your time today.
My pleasure. Thank you, Nishte.